So it's under notes. And it's less than 4. Right there. And I'll create a Dropbox. I just haven't done that yet. Did you guys find it? Okay. I think you're going to like this better. So I'm going to title this Equations of Lines. I'm not sure where you can write it on yours. Okay, we have this form of the equation of a line. Y equals mx plus b. What's m? Ryan, do you remember what m is? That's the slope. And this is, what's b? Jake, do you remember? It's where we begin, but on what axis? It's you begin on the y-axis. It's called the y-intercept. Well, the problem is, most of the time, we don't have the y-intercept. Most of the time, we're given a point, and either we find the slope or we are given the slope. So there's a nicer form of this equation that can be rewritten like this, and it's called point-slope form. This is called slope-intercept. It's usually where we start off writing equations of lines. I don't know why it really isn't any simpler, Andrew. So yesterday what we did is we were given 2 points. You had to calculate the slope using slope formula, and then you had to find b. And a lot of you didn't like it, and especially if the slope is a fraction, you're definitely not going to like it. I've been doing my best to avoid the fractions. We have this other form, and it's called point-slope form. You are given a point on the line and the slope. Not necessarily, Ryan, the y-intercept. And especially for the MCAs, this is going to be important for you to do. Let's see, I'll find a pen here. Well, what's the slope formula? Okay, we had to do that yesterday. We did a lot of those. Remember what the slope formula is? Corey, what's the slope formula? I want the formula to find the slope. It's y1 minus y2 over x1 minus x2. Okay, you know, that's a proportion. I'm going to put this over 1. Okay, I'm just going to show you where the formula comes from. And it's really easy to use. It's so easy to use, you're going to say, why didn't we do this in the first place? Okay, Riley? So I'm going to cross-multiply that. So when I multiply 1 times y1 minus y2, I have still y1 minus y2. Multiplying by 1 doesn't change anything. And we're going to be even lazier, Jake, and we're just going to multiply m times this. I'm not even going to multiply it out. x1 minus x2. And that is, Brian, our point-slope form, except that's knowing that I have 2 points. What if I only have 1 point? Why don't we just change this y1 to just be y? Still the difference in the y values. Make this y1, doesn't matter, you can call it y2. The slope, x minus x1. And it's a much nicer formula. Because I don't have to deal with fractions, I don't have to deal with arithmetic, unless I have to find the slope. And sometimes I do. So, here's what I need to find and put into this equation. y1, that's one of my points, and that's the other part of my point. The big problem is going to get the x's in the x position and the y's in the y position, and I have to do the slope. So that's the formula. So now we're ready to start. So I'm going to go through here, and there's the formula right here on my packet. Now those of you who have a hard copy, it's not very big. You might, if you can see it, fine. If you can't, you might want to write it a little bit bigger. I did it to save paper. I don't know if I like that idea. Okay, so I'm going to extend my page. I wrote down the point-slope formula. And what I want to do, see if I can make this bigger. There it goes, a little bit bigger. I'm going to write the equation of the line, and I have to find these things. I have to find the y-coordinate, the x-coordinate, and the slope. And I just substitute in. And we just leave our answer like that. You don't have to multiply anything. You don't have to add anything. You don't have to solve for b, but I'll show you how you can solve for b. So write this down with me. Oh, I got a couple copies for you back there. It's y minus, I'm going to put a parenthesis there for my y1, equals my slope, and then it's x minus x1. And I'll put a parenthesis there too. So at least I do it. Okay, you need to write that down, Corey. Do you need a pencil? Okay, Ryan, you need to write that down. It's not particularly hard. Now, the hard part is getting the x in the right position and the y in the right position. Honestly, it's the hard part. So here is the ordered pair. Which one's x? Which one's x? The -1 or the 5? Remember, it's alphabetical. The order matters. Order doesn't always matter in things, but it does here. And what's my slope? Read the problem. Write the equation of the line with slope 2 that passes through the point -1, 5. So we have 3 numbers to place. What's the slope? Corey, what's the slope? Rule, you just have to read it. Slope is 2. Okay, and all we do is substitute these numbers in. So I like to put the slope in first because that one's easy. This is the slope right here. This is m. So that's 2. And which one's the y value? Because this is going to be the y value. This is going to be the x. Which is the y value? The -1 or the 5, Ryan? Yeah, the 5. Clearly stated there, it's 5. I don't know if I can make it any clearer. And x is -1. Do I care if you simplify this any further? Not really. We will, because I don't like double negatives, but I don't really care. I'll give you full points for that. Is this easier than y equals mx plus b? So much easier. Why we don't teach this in first year algebra, I don't know, but I am. So it's y minus 5 equals the slope, which is 2. And how about x minus a -1? What is that really? What do 2 negatives make? Positive, so it's x plus 1. That's it. If I want to get slope-intercept, we'll do that in a second. But right now, if I ask you for point-slope form, that's all I want. And I don't even care if you simplify it. This answer is fine. And I can put it on my graphing calculator, provided I can solve for y. Okay, Keaton? Focus. Put your drawing away, please. Okay, let's try another one. One's not enough. What if I have 2 points? Okay, so I have 2 points. I'm going to write these points here. It's x, y. It's 3, 5. And the problems you did yesterday were easier than this one in terms of finding the slope. Okay, so there's my points. Okay, Andrew? We have to find the slope. And you missed that yesterday. Here's the form. It's y minus, and I think I'll change colors and put it in red. This is what you have to substitute in here. Equals the slope. Now that's the hard part because I have to figure out what it is. And then it's x minus the x coordinate. So it's x1. Okay, does everybody see? I'm blue there. Does everybody see what we have to find and put in? And I'll highlight it to make it even more obvious. It just comes from the formula for slope. And if I know where things come from, or I understand them, why they are what they are, I remember. Because I know what the slope formula is. You can write down the slope formula. You can use your notes. I don't care. Well, I like to do easy things first. And the easiest thing to do first is to put in y1 and x1. Because there's no work to doing that. Now, does it matter which point I use? What do you think? I'll just leave a little space there. Do you think it matters which point I use? They both lie on the line. No. So which one do you want to put in there? One's easier than the other, to be honest. I don't like the negatives. How about if we take the first one? Which is the y value? 5. So I'll put 5 here. And then we'll put in the x value, which is 3. And now I have to do the hard part. I have to find the slope. Slope is always a number because it measures how steep the line is. You need to focus. Later. You can do that at home. Okay, so we got to find the slope. Do you remember how to find the slope? We just did it. Slope is equal to, and you did it all day yesterday. We'll get a little more practice. I don't know what the slope is. I have to figure it out. It's y1 minus y2 over x1 minus x2. It's easy to get it upside down. So easy to get it upside down. So I like to put my parentheses in. Don't know why students resist that, because you can time me. It doesn't take very long.
7.
I don't know. What are you going to put in for the first y value? 5 or 6 or 3 or negative 1? Which is the y? Jake, you should be doing this with me. This goes in your document. You would put the 5? Oh, you guys, you love to have negative numbers, don't you? I hate negative numbers. Okay, and then what goes here? 6. Once we chose 5, I have no choice. 5 is partnered with which one? 3 and negative 1. And I'm going to get negative anyway, you look at it. So what's 5 take away 6? Keaton, what's 5 minus 6? Positive or negative? Negative. And now this is the hard part. Like I said, use a calculator if you can't do this. It's 3 minus a minus 1. I don't like double negatives, so we'll make that plus plus. That's 4. So I'm not sure you get 7. It's negative 1/4. Yeah, then you did it well. And I'm done. It's done. I don't have to do y equals mx plus b. I can graph this really easily, too, can't I? Can't I just graph 3, 5? It's up here someplace. Negative 1, 6. There's my line. Done. I can graph it right out of this much more easily. Usually the y-intercept is not a nice number. Okay, let's look at this one. Oh, this is good. Now, on the NCAs, you might have to do something like this. Corey, you might, on the NCAs, get a table of values. We've seen it. That first problem was a table of values, except they were real numbers, not these fake numbers. And we have to find the slope. Now, all you have to do to find the slope is see what the change in x is. To get from negative 3 to negative 1, Jake, what am I doing? Adding 2. Excellent. Let's see if this works. Negative 1 to positive 1. Am I still adding 2? Yeah. To get from 1 to 3, am I still adding 2, Corey? Yes. And remember what slope is. I'm not going to use slope formula. I don't like to use it unless I have to. It's the change in the y. If you haven't seen the delta, there it is. And the change in x. As long as I'm consistent, Ryan, about working down my table, I'm going to be okay. How about 5 to 8? What's that change? Plus 3. I'll give you a little secret here. You're doing calculus. Some of the stuff in calculus is just like this. And 8 to 11 is plus 3. 11 to 14 is plus 3. That's how I know I have a line. These things are always the same. So what's the slope? It's either 2 over 3 or 3 over 2. What do you think? It's the y over the x. So what do you think the slope is? The change in y. What's the change in y? 3 or 2? Look at your chart. It's 3. And what's the change in x? 2. There it is. I want to write this in point slope form. So, what's the formula? Does anybody remember? It's y minus y1 equals my slope, and then it's x minus x1. What numbers do we need to fill in? Which ones are numbers? I got a lot of letters. Keaton, what are the numbers? y1, what's another number? And works for m for me. And what's another number? Evan, do you know? Which one's a number? I know it looks like all letters. That's the reason why this is not necessarily a good formula. x1. The x1, y1s tell me I'm looking specifically for a point here. Which corner would you like to use, Andrew? Doesn't matter to me. It's y minus something equals the slope, and it's x minus something. Which ordered pair would you like to use, Andrew? It makes no difference. It all is the same. Of course, I don't like the negatives, but we can do whatever you want. Which ordered pair do you want to use? Give me one. There's no 2 there. Give me the ordered pair. I don't understand what you mean. Give me the name of the ordered pair that you want to use. I don't care. What's the x-coordinate you want to use? All of you can write different ones, by the way.
5.
There's no x, that's 5. X. Andrew, give me one of these ordered pairs. You got, it doesn't matter, but all right, which one do you want to use? He wants to use the negative 3, 5 point. So what goes in right here? It's the y coordinate, so it's the 5, that's right. And the x coordinate is negative 3. I don't like those negatives, but that's okay. And what was the slope? We have it written down. What goes in for slope? You should be doing this with me on your iPad. It's 3 over 2. Are we done? Yeah. Especially if you have fractions, this is a much easier way to do it. What could I do with that those 2 negatives, because it looks kind of ugly? What do 2 negatives make? Plus. X plus 3. I'm done. Jake, is that easy? Or is that hard? Yeah, it should be easy. You may not remember where the formula comes from. I can live with that. Here we have to read the slope off the graph. And so it's going to be y minus y1 equals m x minus x1. You got to give me a point on the graph, and you got to give me a slope off the graph. Ryan, can you give me a point? It has to cross the grids nicely. Well, I need an ordered pair, that's right. What's the x value at that? I think Corey's talking about this one. What's the x-coordinate on the y-axis? Always. No? What's the x-coordinate here? The x-coordinate there is negative 2. What's the x-coordinate here? Only number that makes sense. Andrew, what's the x-coordinate there? What's 5? You're right, this is 5. But what is 5 there? X or y? It's the y value. When you measure the x, you're measuring how far you move right and left from the origin. How far did you move from the origin on this one? It's okay, it makes sense. You didn't move, did you? So what's the x-coordinate? 0. So Corey wants to use 0, 5. Could I use another point on my graph? Sure. I could use this point if I wanted. I think it's kind of nice. Things are different than when I first started teaching algebra. When I first started teaching algebra, we didn't have graphing calculators. You couldn't guarantee that those points went through that line, or that line went through those points without actually doing some more algebra. Okay, now for the hard part. What's the slope? Jake, you remember how to find slope? I'm going to find something close to this point. This looks pretty good. Is the slope positive or negative? It's negative. Now, what's wrong with counting? Counting's wonderful unless the numbers are not nice. These are nice numbers. So what is that, Keaton? Make your little triangle. What's the change in the x? What's this distance? 1. What's this distance? 2. So what's the slope? 2 over 1 or 1 over 2? 2 over 1. You can put the 1 in there or not. I don't care. Okay, do you remember what the formula? Oh, I have the formula up there. There it is. So it's y minus, what's the y coordinate? Got it written right there. What's the y coordinate? 5 equals my slope, which is negative 2. I'll put the 1 in. And then it's, whoops, sorry. x minus the x-coordinate, which is, what's the x-coordinate? 0. I'm okay with that answer. Jake, that's okay. You could make it nicer looking. You could go y minus 5 equals negative 2x. Could I solve for y? Couldn't I solve for y by adding 5 to both sides? We know how to do that. You guys have passed the test, several tests on that. I know you know how to do that. What's the y-intercept? What's b? Whoops, wrote b. What's b? You guys awake out there? Barely. What's b? M x plus b. What's b? Nadine, what's b? What's b? Well, it's lined right up. M is negative 2. X is there. Plus is there. What's b? 5. So I can change it. Guess what we're going to do on the last page? We're going to change it. Here it is. Here's the first example like that. I might have two. I don't remember. And then we're going to get to work, and you're going to try these problems on your own. Okay. I want to change this to be y equals mx plus b. Pretty soon, when I first solve for y, we're going to do Calc 2. Because I know where the calculus goes. Okay, let's get y by itself first. What could I do to get y by itself, Adine? I want y all by itself. Forget what's happened over there. I don't care. How do I get rid of minus 3? Plus 3. And I'm going to put it over here on the right side just because it's nice. Actually, I'd almost rather have it in the front, but it doesn't really matter where you put it. So y equals negative 5 times x plus 1 plus 3. You know what? This is going to be on your final exam. Can you simplify that? So we're constantly going over things that you're going to need to do. I'm going to get into y equals mx plus b. It's not quite there. Because y equals mx plus b looks like this. Oh, that's much harder. When I take a point and a slope, I just plug it in, I'm done. Even if you want to take an equation and put it in y equals mx plus b form, this is still easier because I don't have to do fractions. So let's go ahead and distribute that. Do you remember how to distribute? What's a negative 5 times x? Negative 5x. Isn't algebra easy? Because it honestly is easy, Evan. That's all there is to it. This is arithmetic. What's negative 5 times 1? I don't like arithmetic either, I'll be honest with you. Negative 5. Negative plus 3. Simplify. Let's add those. So y equals negative 5x what? Minus 2. Just to make my point here, this is actually easier. The point this goes through is negative 1, 3, and the slope is negative 5. To do y equals mx plus b is a lot more work. First, I write y equals mx plus b. To put this into this form is one step. I'm done. Now, to do y equals mx plus b, I got to put in then 3 equals m, which is negative 5 times x, which is negative 1, plus b. A little more arithmetic, right? So 3 equals 5 plus b. Then I have to subtract 5. And by the way, when I looked at some of the papers, you didn't finish the problems. That's the problem. That's negative 2 equals b. So I get y equals negative 5x minus 2. To put this into this equation is one step, and these steps are easy compared to those steps. The minute I give you fractions, you will agree. You will definitely agree. And I can give you one really easily if you want me to. I've tried to avoid fractions because I want the concept. Okay, there you are. Let's do number 1 together. And all we're going to do is point slope. These should go fast until you have to calculate slope, then they won't go so fast. So what's the formula? Y minus y1 equals the slope x minus x1. These are what I got to find. Okay, I'm trying to get rid of that bar. There we go. Can I move all that? Oh, not that. No. Okay. So Keaton's going to help me with this. It's y minus, and should we put xy here so we get it straight? What's the y value I'm going to put in there? That's right, -3. Okay, Corey? Equals, what's the slope I'm going to put in there? Because now I'm going to put in slope. What's the slope there? Not negative, 2. And then it's x minus, what's the x value? Now don't get this minus confused with that minus. They're not related at all. What's the x coordinate? It's not 1, it's -1. Can we simplify that at all? They're two separate problems. We're almost done because I'd like to simplify that. What's this end up being? Right? What is y minus a minus 3? You know what minus 3 is? What do two negatives make? Yes, so you do. Y plus 3 equals 2. X. What's that going to give me, Andrew? Andrew, are you here? Andrew, what's a minus 1? What's minus a minus 1? No. Two negatives make a positive. That's it. That's it. Will I accept this? Oh, probably. Because that's the concept. The rest of this is practice with arithmetic. So these should not take you very long. Try number 2 and I'll walk around and check. And that's what we're working on today. Tomorrow we're going to do the hard things. Word problems. Story.